Okay. So let's again revise for TRC that we already covered in the previous class so that we can extend it further, right? So this was in the TRC, that is tuple relational calculus. We have the expressions and formulae how we used to form the TRC, right? We know and we understand like TRC can be an expression of TRC basically can be of the form S1.A1, S2.A2, and so on till Sn.An, right? These are what called tuple variables, right? That is Si are my tuple variables. And this is what some formula that is well-formed formula of S1, S2 until Sm, right? Make sure M should be greater than equal to N, right? So this formula can be atomic formula or it can be a recursive formula that is combination of different atomic formulas, right? We understood what is an atomic formula. For example, we say any R belongs to relation, probably R dot A, OP, R dot B, or we can say R dot A, OP, S dot B, OP some operator, right? This probably can be even atomic formula as well, along with R dot A, OP constant values, and the same goes for constant OP S dot B. This probably can be atomic formulas as well, right? Then we so a recursive formula, how a recursive formula we can form, right? Any atomic formulas can be recursive formula. And then we saw if P and Q are same formulas, then negation P, like this one, negation P or P or Q, P and Q and so on can be one the formulas as well, right? Okay, just a minute. Yeah, so fine. Yeah, so this is what we have seen, and probably after that we saw that any recursive formula may contain there exist some tuple variable s such that f of s, where s is some tuple variable. All this term for all as well as for universal quantifiers we can say the same. So any recursive formula contains such type of format is your well-formed formula, right? So the concept and the theory we have already seen in the previous class. Let's move on to some practical examples now, how we will form some TRC queries by using the concept that we have understood so far. For example, let us take the example something like we have a relation that is student. We have SID and S name and also CID, some specific example, right? This is my table. The query is, see, understand, for every question, each and every question, first we will form the relational algebra query, and then we will form TRC, then probably DRC and so on, right? Because with the help of this one, TRC, and if you form the relational algebra query, you will probably find it easy to form TRC query as well, right? We'll show you how. For example, now the query is we need to records, retrieve records of student where their course ID equals to C1. Understood? How we need to retrieve the records probably, right? And of the student whose CID, course ID is equals to C1, right? So it's an very easy, probably we can form a relational algebra query in an easier way, but it could be from the student relation. We are simply going to select those rows in which CID equals to C1, yes or no? Very easy, right? Since we know row, that is also this selection operation probably works on your rows, and projection operation works on your attributes columns, that we already know. So it will retrieve the complete record, that is record of the student whose CID equals to C1, right? Now see how we will formulate the TRC query for this one, the easy one, right? First we'll do some easy examples, then we'll move on to the complexity part, right? Okay. So how we will write TRC? Understand, this is my student table. Just try to visualize the things here. Complete a mathematical way, you will be able to understand. For example, this is my student table. Now this student table, I will point out to the instance. For example, I will look at the instance of this table. How? I will take variable, let's say T. T is something For example, T is something that belongs to, and let me take small t better, right? Small t is something that will point to the instance of my table, that is student, right? So what I'm saying is already we know the format, right? The curly braces and then some pipeline here, right? This way. We need to write here tuple variable and we can formulate any well-formed formula here, right? Understand now. Let me say this T is the instance of the student table. So what it can be? I will say T belongs to student. T belongs to student table, right? That is correct. Fine, because T belongs to student table. And what I'm saying is T T dot attribute name. Which attribute we want to retrieve? CID. That is T dot CID equals to C1. Yes or no? And curly braces. What we are going to project is T here, right? So in this way, you can formulate a TRC query here. We are going to retrieve only those T in which T dot CID value equals to C1, and corresponding we will project our T, right? There is a other format, right? Probably you will find out the other format as well. Maybe even the books you can just find out how they used to write is they have taken student table and then in the square bracket they have written small t, something like this one. It says what this is just like you can just think of analogous to array in C programming, some value and then t index value, right? And what they do is t of CID equals to C1, and they simply say project t here. This T will contain, this T is a part of student, and this T, the attribute value T dot CID will give C1 here, right? So this T is pointing, this is T. This T is pointing to the complete in row here. Yes or no, right? So very easy in the very beginning. So understand, let's practice one, more small examples, and then we will move on to the next further. For example, now I want to project some specific attribute here. Like, for example, if I say in the same example, I want to project SID from student, simple SID, right? So relational algebra queries, quite simple. From student, right? From student, project SID, right? Now see TRC for this one. See, understand one thing. For writing a TRC query, probably there might be not a specific format of the queries, right? Understand here, the difference is how you're formulating the logic here. And this logic should be correct. It must be correct. Probably you might write that logic in a different ways, but definitely your ways can be different, but the logic should remain the same, right? How I mean to say, understand here, we will see different formulation for one query, right? I will say that there is an instance T that belongs to student, that is student table, right? I can write here T, but as we have seen, our the formulation part here, in this tuple variable, you can have the format like the tuple variable dot the attribute value. Yes or no? So here you can write T as well as you can write T dot SID if you want to, reflect that. Right. You can ask why in the previous we haven't included. Probably you know. Reason behind T should project entire row here. You cannot specify any. And if you want to, then you need to write every attribute T dot SID, T dot SName, T dot CID. So definitely, probably we write only T will retrieve all the record here. Now I hope you have understood why it's T here. But here I want to reflect the specific attribute here. So that's why I need to write T dot SID, right? There is another way for this one, and probably close this as well, right? I can write something like this one. See, always remember, try to understand how I am writing the queries. there is a way, specific way how we used to write. I am first writing this well form formula, and then I am just writing this tuple variable that I actually want to project or say the reflect, right, as a part of query. I mean, the output that we actually want, we are going to write later. First, we write the formulation, well form formula here, right? Okay, see, T is my instance variable that belongs to table student. And I am saying that what I need actually, I need t.sid. Yes or no? I want to reflect this t.sid, right? Probably I will store it some free variable. Let's say t equals to t.sid. We have seen in the previous class what are bounded variables and what are free variables, right? Here, free tuple variables which are not bounded by any quantifiers, right? So we have seen like t dot si t dot is, this is what, this t is what, free variable. This is not bounded by any quantifier, but bounded variables, these are bounded by some quantifiers, right? So here t is not bounded by any quantifier, that is t is not, bounded by any there exist or for all such type of condition. So t is my free variable, right? And I told you in this tuple variable instance part, right, we cannot have bounded I mean, we cannot have actually the quantifiers here, right? So bounded variables are restricted here. T is my free variable, so I am just storing t dot sid in the capital T, and this is what I'm going to reflect here. That's it, right? So this is another way you can probably write. And see, there is one more way, I mean, that just to explain you, right? Understand, let's say t belongs to student. T belongs to student, and I what I need to find out is t dot sid. I need to find out t dot sid. Where I'm storing this, I am taking some other free variable where specifically I am storing sid values only. Understand, s dot sid, right? Here I was having any tuple variable. This free tuple variable can store any type of any domain of your attribute specifically, right? Here specific we have the sids, that is the domain is integer or say number here, so it is going to by default take t values. But here s dot sid, it means specifically it is restricted to take integer or say the number values here. You cannot change this one, right? But this is again a method, so that's why we have included. And out of this you can project or say you can give output as a s here, right? So see, these are different ways probably with the help of which you can easily write any trc queries here, right? Okay, let's do one more example, right? You will be able to understand more, right? Okay, in the previous example, let me take something like retrieve, not single attribute, actually, SID and S name from student. Fine. Retrieving SID and S name from the previous example, right? What should be the relational algebra query here? From the student table, we are going to project SID, S name. So I hope now you are able to, you should be able to write the query for this one here. Let's try to find out TRC for this one, right? See, I'm writing the pipeline here first and see T belongs to student. Fine. T is the instance variable that belongs to student. I will point to every tuple of my student table. And what I mean is let's take some we want SIDs, right? So I'm saying is S dot SID is equals to T dot SID. The previous example, right? In the same format we are writing, we will see different as well, right? So S dot SID contains T dot SID, but this is not sufficient because I need to have S name as well. Now S only can store SIDs here. It cannot store your name values. The name is your varchar or varchar2 data type domain, right? So for that, I need to specify S dot S name is equals to T dot S name. And then I will simply going to project S here. Understand? See, let me be more specific and clear why, and say what
सर
actually
उसके लिए
this
हमें
part
एक
is
और
doing.
लिखना पड़
Yeah, hold on. Let me just explain you what and why this part is being used here. Right? Understand? Let me just tell you. When I'm taking the S part here, right? In the background, you can just think, visualize this one. In the background, my S was created. Right? In the S, when I write S.sid, some SID was created. And in this one, I have all the SID's values. Right? Then when I write S.sname, some S name was created, and those specific S name values were there. And when I call this S value, it retrieve all those values which actually stored, right? So this is how the way you can visualize though, right? Just to make your concept more clear and understandable, right? Now ask what you were just saying.
got it sir. I thought sir what will happen if we write s belong to a student
No, if you
t
write S,
comma
okay,
s.
yeah. If you write S belongs to student, it means to say what? You are for actual table, that is for your actual table that you have student. Now this S is pointing to here, right? But if from where you will find out this one, how you will retrieve again here S, then you need to specify some other variable here, probably T or Z or A dot SID or something like that, because in the table you have a lot of values. To select some specific value, you need to take the help of some extra instance variable. And for example, I'm saying T here, or I am saying S here, because this is actually, it will take out the selected values that you actually want out of the table. That is what my SID and SName. You can take it S here, but then you will need to write out T dot SID equals to S dot SID and so on, right? So to
Okay sir.
dig out the values from a table, you need to have some tools in your hand, kind of. This probably S is that tool here, which with the help of which you are comparing T and S, and in this way you are reflecting the output here, right? So basically, to understand this scenario, this kind of scenario, you can just visualize in this way here, right? Probably it will make you more understand. Again, let's see another example, the same example and different way of writing this query, right? See, understand, the queries can be optimized, right? Just like your, see, this is a programming language, right? And in the programming language, when you write any programming code, optimization works there, right? Again, we have in programming language time complexity and space complexity. Probably you have already more familiar with how the time complexities are managed in C programming, Java programming, or even in Python, if you are familiar with, right? Again, this same thing goes to SQL as well. In structure query language, we have the time complexity, right? When we'll do the the structure query language part, when we'll do that in, if you have already done in the lab so far, we use group by clause, we use having clause, all those. In there, we will see how time complexity is calculated, right? So I mean to say is, the queries are written here, but that there can be different ways, right? It based on optimization, which one is more correct, right? Correct means more optimized format, right? For example, let's see for the same example here, I'm writing in this way. Let's say T belongs to student table, right? Fine. And now see, I am taking what I need actually is T dot SID. Yes or no? I need to find out T dot SID. Now let's say I am just storing this T dot SID in some free variable that is capital T. Fine. Now SID is not sufficient because I need S name as well. So what I will do is T dot S name, and I'm gonna store it some other free variable. Easy one, right? Since I need SID and SName both, so definitely I need to have T and S. That is T comma S. So this example states that obviously you can have multiple values here, right? So in this way you can store value, but see, this method is less preferable. Why? The reason is you need to create a lot of free variables for storing some values, specific values, until and unless your data set contains less number of attributes. If your data set contain more number of attributes, this method becomes kind of hectic. You need to store different a lot of free variables, and then you need to reflect. In that case, probably this method will be more recommended, right? So again, this based on situation, but definitely we have seen both the aspects of writing the same query in a different way, right? So I think this is enough. I mean, let's try to understand. So far we haven't included any quantifiers here, right? Okay, let's do that. But for that, let's take our regular examples. I mean, the examples that we have covered in our in the previous relational algebra queries part there, right? Okay, so see now, we have um, okay, let me just take out the example. I don't remember the example. Give me a moment so that I can write all the tables. Yeah, here we go. We have the course table with CID, CNAME, and instructor. Right. We have students. So since beginning, we are working on this example. Right. We have almost covered the queries for this example in almost all the small topics. Then we have the enroll table. We have SIDs and CIDs collectively defining this one and the fee here. Right. This is what we the example we are taking. Right. Now see, understand the what I mean to say here is, if I put a query like retrieve SIDs enrolled in some course taught by some instructor, let's say Korth, Navathi or Korth, Ullman or right? Okay, right. So I think you can easily formulate this query, relational algebra query for this one, right? So let's first write the relational algebra query here, right? What I want is SIDs SIDs of my course. I mean, I need the course as well, in which instructor is Korth, right? See, uh, I can get SID from which table? Enroll table as well as from student table, right? Now I want the course stored by the Korth. So this instructor Korth can only be found in the course table, that is here, right? But I can get SID from enroll. Until and unless the question was, you need to find out the name of the student who enrolled in some course taught by Korth, then definitely you need a student table as well as enroll, right? But now the query is, we need to find SIDs only. So there is no need of student table so far. We can get the SIDs from enroll and using course. This is the way how we do first selection operation in the queries, relational algebra queries. Okay, that's fine. So now let's take enroll table. I have taken the enroll table and I will do the joining. Yeah, I will do the natural join of enroll with course. If doing natural join with enroll and course works on the same attribute, that is what CID, right? But in the course, let's select out those tuples in which instructor is course, right? So I will perform the natural join, but before that, I will find out those instructor, that is select from the course where instructor is equals to course, right? I will perform the join, that's fine. And then after performing the natural join, I may reflect the SID. This is what actually I want, right? So relational algebra queries, yeah, that's easy. We can formulate, no worries, right? But now TRC, this is what actually we want. Understand now. Uh, I think it is covered. Yeah, right. See, keep in mind whenever understand, see, remember one thing, whenever you are solving the TRC, keep in mind about the tables that you have considered. That is very important, right? You should have in mind what tables you are just working on, right? For, okay, that's fine. Now see, what I'm doing here is, I am saying the name T1 to enroll table. For example, I am saying T1 is my enroll table, right? Instead of here, let me write T1 for enroll table, and I will say T2 for course table. These are what my instance variables, for example, tuple variables, right? That I actually want to work on, right? Now understand, see, T1, there exists some T1 that belongs to enroll table, right? There exists some T1 that belongs to enroll table, and there exists T2 that belongs to course table. It means what? Every tuple of enroll table is being pointing to T1, or say T1 is pointing to everyone. T2 is pointing to course, right? There exist, right? It means we need to find out those specific which for which actually we are looking for. And what are those? See, in this one here in the course, what I actually want is, see, T1 dot, you see, you can just formulate from here. This is what natural join. Natural join is working on what? CID, yes or no? CID should be same. So it means what? The T1 CID of T1 should be equal to the CID of T2, right? So that is what? T1 dot CID should be equal to T2 dot CID, right? And this is not sufficient. Since we are working on the course here, out of the course we need to choose the instructor who is course, right? So that's what course is being pointed by T2. So T2 dot what, we write instructor, right? The attribute instructor, it equals to some course, right? So with this one, what actually we have done is we have performed this task, this natural join, yes or no? This natural join is on this part, and this instructor is on this part. But what we actually want to project? SID, right? For that, what I can take is I am taking an free variable which is actually storing the SID. But which SID? That is from enroll, right? Why? Because we have written some courses here, right? So there exists at least one. For example, I'm what we can say, T1 dot SID, and out of this one I can write T here. Any doubts so far in this one, understanding this? Here you can write and operator, or probably it's your choice. We can generally use to skip, but in different conditions this and operator should be used here, right? This and this and this, right? So it's not easy. I mean, it's not difficult. Sorry, it's easy, right? But when you will see the query, you may find it difficult. This is one, it's a kind of thing that generally, it's a psychology. When we see any TRC query, right, without knowing what actually is being done here, we will find out, oh, it's very difficult. I mean, right? But the moment when we will start understanding the query, TRC query, you find it's quite easy, right? Seems to be complex and difficult, but it's very easy. We are actually doing what we already know in relational algebra. For example, let me show you another way for this one, right? Let's say I want to retrieve. What we can do is, uh, okay, let me take some easy examples so that we can uh, formulate the query for that. Okay, I'm just writing the statement here. You are asked to retrieve. Let me write on a fresh page because one query will at least take one page. Yeah. So retrieve, understand, retrieve some course ID, right? Okay, let's take the course IDs, right? Means the course IDs in which instructor is course, right? It means to say. So we need to retrieve those course IDs enrolled by some student, enrolled by some student who paid. So let's include the descriptive attribute as well, who paid fee more than 5,000. I have just formulated this query, right? So we need to retrieve the course IDs of instructor course, right? So these are the students, some student who are enrolled in the course ID, who are enrolled in the in some course, whose instructor is course, right? And paid the fee more than say 5,000, right? So before that, first try to understand using your relational algebra query, right? So before that, what are the tables that we are going to use here, right? See, we have these tables, right? We need to find the course, fine, that is, and even the instructor, so definitely we need the course, right? And then we need to find out the fee part, and fee is there in the enroll, right? We need SIDs as well, some SID, so definitely we can get it from enroll as well. So in overall, we need course and your word enroll here, right? Okay, see now how we'll write. Uh, we need enroll table, that's fine, right? Since, okay, first understand, let's do cross product here, right? And see, after doing the cross product, it means what we have done the cross product of enroll as well as course, that's fine. See, just try to understand, I mean, how I am just writing the query relational algebra even, right? You should follow the same way. This is what the understanding that you should have. Once I did the enroll and course table Cartesian product, it means what, for every SID, for every CID I have, link with SIDs and all those things, because the cross product is, let's say, doing on CID. For example, we have the common part, right? So what I will do right here is I will select those tuples in which enroll dot CID equals to course dot CID. This is what, right? This means what, I have done some joining between common attribute. I will select only those tuples in which we have the same CIDs for these both, right? And this is not sufficient. We need the instructor now, right? Because we need the instructor as course. So instructor equals to course here, right? So course dot instructor, that is not required because probably we have different tables. Even you can write, that's not wrong. Also, it's not only the course, we need to have a look at fee as well, and that is what, fee should be greater than some 5,000. So this is what specifically I have the constraints for the selection of tuples from Cartesian product of both. And then out of these all, I'm going to simply project what? Course IDs, yes or no? This is what I want. So that is what you can write, course dot say CID or even CID as well. Both works fine. This is what the relational algebra query for this one here, right? So you can just think, I mean, it's an easy, but let's move on to TRC. This is what actually we want, right? So how we will write TRC? Again, same way, right? Okay, someone find that if I take every time T1 to enroll and T2 to course, probably this might be the fixed syntax. No, there is nothing like that. In this example, let's take converse, T1 to the course and T2 to the enroll, so that you will be able to understand in a more clear way, right? It's not like that specifically it should be T1 to enroll only in the entire tables. That's not required, right? If you will switch the values for this one, probably you take the query and you give T1 to the enroll. In the second query, if you give T2 to the enroll, you need to think more in that case, because more you will think, more your concept will clear, right? Just keep this thing in mind. If you really want to make yourself better, then just try to change the things that you have done previously, right? Because again, you will think for the same, and then definitely you're gonna improve your understanding, right? Now, for example, I will just take T2 to the enroll and T1 to the course, right? Understand the query now. Okay, pipeline. Let's formulate the WFF, well-formed formula. I'm saying is there exists T1. Okay, let's formulate now. There exists T1 that belongs to some course, right? T1 belongs to some course, right? And there exists T2 that belongs to what? Enroll. Fine, understood so far. Now see, what actually we will do now. We will just simply write these condition, nothing more. You will understand. See, what I'm saying is T1 dot CID should be equal to what? T2 dot CID. Yes or no? Right? CIDs should be same. And instructor, right? Probably I am just writing. See, here I need to write the tuple variable. In the relational algebra, this is what the difference. I can just write instructor, the attribute name directly. But in TRC, if you want to access any of the attribute of the table, you must have to include your tuple variable. Keep this thing in mind, right? You must have to include, because we are pointing, and this is for this purpose we have included these tuple variables here, right? Now see, I am saying from T1, right? Because from the instructor I will get from course, that is T1. T1 dot instructor is equals to what? Let's say Korth or Novate. Yeah, we are working on Korth, right? And we need to look at the fee part, right? We need to look at fee part. So that is what? Fee is in enroll, that is T2. So T2 dot fee should be greater than 5,000. Okay, this is what we have written the condition. Okay, someone can ask, or say someone can say that we have written these things. Can we write T1 and T2, because T1 is pointing to the CID, T1 is pointing to instructor, T2 is pointing to fee or something like that. Can we reflect T1 and T2? No, right? Understand? Here T1 and T2 are what? These are what? Bounded variables. But this part must contain your free variables. And due to that reason, even, for example, here we need to reflect the course IDs. I can take another variable that is free variable, which will actually store only course IDs. Course IDs are available in T1. We are looking for from T1 here, right? Why? Because the instructor of which we are talking of the course is from course table. So we will reflect this one from CID here, and then I will put it here. I think it should be clear. Let me know if you have any doubt. Right. So in this way, I mean, literally we can do practice, and there are a lot of questions. I mean, we have whatever question we have done so far in relational algebra, you can just try to write the specific queries of TRC here. For example, I'm just leaving this one on you. Let me know if you face any issue. I will just explain it probably in the next class. We need to retrieve SIDs whose age, let's work on age now, age more than 20, age is more than 20, and see, and I have used and enrolled in some course taught by Korth, or let's say Korth courses. So I have used and operator here. Right? So you can formulate the queries, one query for more than 20 and one query for some course code taught by Korth, right? Okay, let's do this one as well. I mean, we have used a connective operator between two different queries, right? Although it's same, but let's try to format this as well, right? Then next question I will just leave on you. Okay, first finding the relational algebra query here. How we will write the relational algebra query. Okay, so yeah, first finding out the age more than 20, right? I'm going to simply select from where I will get age, from student table. Yeah, right. from student table we will get the age, right? So from this table that is student, I am going to select the age greater than 20, let's say, right? And I what I want SID. So simply I will project SIDs. Then we have AND. So AND operator, right? So we have the AND operator here now. Now find out the enrolled some courses, SIDs of enrolled student who enrolled some course taught by course, right? So that's again easy. We have done these such type of queries several times. So from the course, I'm gonna choose only those in which instructor equals to some course, and then I will simply project what SIDs. Right. So this is what the relational algebra query that we have. Right. So now see how we will write the TRC for this query now. Okay. See the TRC. In this one, what I'm actually doing here is, let's say, I'm pointing the student table. Why? Because see, first let's write the TRC for this part. Right. Same goes here, right? There is no difference. I mean, you can take this part as a one TRC query and this other TRC query, and you can use AND operator to combine both of them. Right. So what I'm to say is, let's say I'm taking there exists T1 that belongs to some student table. Right. And what I actually want from here is T1, the T1's age, that is T1 dot age, should be greater than 20. Right, this is what. And see, understand one more thing I am writing, and T equals to T1 dot SID. See, I have written this, completed this query for this part. Right, you can just ask why I have written this one, will tell you. Right, so this is what for this part here. Now again AND operator, so as it is AND operator. Now let's formulate for this part. Again we need enrolled and course here, right? So understand, I have taken instance variable T1 for student. Since this query is over now, we have understood, we have found the output for this query, right? Now understand and keep keep this thing in mind, that instance variable, see the tuple variable that we have used here in this query, that is T1, you can reuse that for solving this query, right? There is flexibility that you can use, and this is what actually I'm doing here. For example, I'm saying there exists T1 that's belong to your enroll table. Now I'm pointing T1 to this one here, right? So there exists T1 and also there exists T2 that belongs to your course, right? Understand now what condition that we need to use here. The same, since natural join is there, so CID should be same, because we are doing performing the natural join over same attribute, that is CID. So what's that? T1.CID equals to T2.CID. Fine. And instructor should be course here, right? So T2.instructor is equals to course. Understand now, and I need to include some free variables so that we can, we can project those free variables values here. Understanding this one, I have taken free variable T here. Yes or no? Now in this T I have SIDs. Don't I need the same T, I mean the same SIDs that should be working here as well as here? So what I will do here is, I will take the same variable T and will store T1 dot SID. Understand, this T1 dot SID is different. This T1 dot SID is different. Why? This T1 belongs to student table. Rather, this T1 belongs to enroll table. Right? And then we can simply close it. And I will simply reflect T here. See, it's not difficult, right? This is what actually we need to, write the things that we have actually covered so far, right? See, this is what actually non-procedural. Why we used to say this part as a because we know what actually we want. We know here what actually we want, but we are not specifying how the things are working in the background, right? Remember, SQL is also a non-procedural language, right? The procedural language is your relational algebra only, right? Okay. So if this is clear, then I'm just leaving one query for you. You can just, practice for this one. This query will be on the same example. The query is you need to, retrieve. Okay, what you can do is you need to retrieve SIDs enrolled in only one course. You need to retrieve SIDs enrolled in only one course. See, only word is used. So I hope you know what you have to do, right? So you can just think of, understand. Okay, let me just give you a small hint here, probably, because this can be other, different type of example, but actually we have done. So what you will do for only, I'm just giving you an idea. You need to retrieve SIDs enrolled at least one course. Then you will do difference operator of set difference, that is of SIDs enrolled what in at least two courses. So how you will write this set difference in TRC? Probably you can easily formulate now the relational algebra query for this part, right? But to find for TRC, what actually you have to do when you have set difference operator? For example, first you will write the TRC for this one, right? Let's say you have written this part for this one, that is TRC1. Let me write. So this is what TRC1 you need to formulate. Then we have this one, set difference. I told you this is what calculus, right? This is what calculus. In relational algebras, this is but not is simple a difference, set difference. But in relational algebra, I told you you should keep these things in mind. What you will actually have to do here, right? In relational algebra, when we say P and Q are my two, say two propositions, P but not Q, how will we write? P and negation Q in relational algebra. And if it is your calculus, P difference Q is the meaning of but not, set difference, right? This is what the difference that we have already covered. So things are repeating here, and this is important for you to keep these small points in mind. So since this is against a difference and TRC is a part of calculus, what we will do? Use AND operator and negation. And negation. And let's say this is for my TRC2. And here I will write TRC, whatever TRC2 that you will form. This is how you will reflect. Right? So this is the way that, and this is the thing that I was actually telling you. Now you can just formulate the query for this one here. Hopefully you should be able to, right? Just let me know if you face any issue in writing the query, right? Okay, I mean, our examples will never finish, right? Because we have already done a lot of examples in relational algebra, right? If we again, started writing the TRC for the examples that we have covered so far in relational algebra, probably it will take, 1 week lecture to finish an hour. So this is what actually I'm just
सर
telling you. Huh, same.
सर वो जो एक क्वेश्चन था ना कि सेकंड हाईएस्ट सैलरी निकालो एम्प्लॉयज की,
Yeah.
वो वाला अगर एक बार टीआरसी से कर देते तो सारा क्लियर हो जाता.
Yeah, okay, we will do that.
सिर्फ
Right,
वो
but
एक
before
पार्ट
that,
कर दी.
for TRC, but before that, you should know the relational algebra query. right? Then only you are moving to TRC there, right? But okay, fine, that we will do. Just hold on, right? Let's just finish this part. Okay, very small left for this TRC part here. I hope you have understood so far till this one here, right? So understand one thing here. Let me just write down. Yeah. See, we have something called as unsafe TRC queries. What are these unsafe TRC query? Right. Understand, since this is again a programming language, right? Tuple relational calculus. Since we have already, we are already familiar with such type of things. When we write any programming code, this programming code or say some kind of loop we are just forming. For example, if I say for loop, right? The loop may go into infinite, right? So loop may run for infinite number of time. It will never terminate, right? We are already familiar with the scenarios in the C programming and other programming languages. The same type of scenarios may happen in your um, this TRC as well, and such queries are called your unsafe TRC queries, right? So TRC query with infinite set of tuples in the result is your unsafe query, right? How? See, I'm writing, for example, T is my tuple variable, and I'm saying T does not belongs to student. I have a student table, right? In this student table, T is my, let's say, some tuple variable. I need to print out those tuple which are actually not a part of student, right? How I can formulate this in logical mathematical logics. So this is what negation. Negation of T belongs to your student. This is the query. Right. Here's these are the set of tuples T. Those are not belonging to the student relation record relation. This is what, right? So these are called your unsafe queries, right? So and remember this thing. Just to restrict these unsafe queries, what actually database system does is whatever the domain we are having. For example, this T domain should be restricted to this specific table values only, right? So our domain should be within the table, right? It means what? This T should point out to the tuples that we are having actually in the database. It should not go beyond that. If it will go beyond that, then definitely will fall into infinite loop, right? So we are avoiding this by defining the domain of relational table, right? So such type of queries are basically called your unsafe queries, right? You should have an idea of what are those, right? One more small point, and what's that? The expressive power. We call the term as expressive power. Expressive power. Let's do the comparison. This thing is you if you are familiar with your the course theory of computation, there we need to find out the expressive power of your finite automata with your push down automata and then with your Turing machine, right? I think you don't have that subject so far. Maybe in your next semester you will be having, right? So in compiler design and theory of computations. So again, there we used to perform expressive powers basically, right? This term came from there. Now let's see what's the expressive power in this one, your database, right? The queries which are, not falling into infinite loop or your safe queries. So falling the query in infinite loop is your unsafe query, right? So expressive power, remember always expressive power of say safe TRC queries I'm just talking about is same as the expressive power of TRC queries is same as the expressive power of your basic relational algebra queries. Remember, right? It's not like, see, understand the expressive power, right? The term what expressive power says. Uh, Understand, we have a scenario. For example, I'm just writing this retrieve SIDs enrolled in only one course. If I'm writing this statement something like this one, Can I formulate this query in TRC format, or can I formulate this query in basic relational algebra? If I can formulate this query with TRC, then definitely I can say that I can formulate the query with relational algebra as well. This topic is, this is very interesting topic. I mean, this is quite familiar with your Turing machine, right? If probably you will understand that very interesting topic, right? It says what if you cannot write any query for this one. For example, you cannot write TRC for this one, then definitely you will not be able to write the query for using relational algebra as well, right? So expressive power same means, if you are having a set of queries, for example this set of queries, right, you are having n number of queries. For those n number of queries, you can, if you can write TRCs, then definitely for those n queries you can write relational algebra as well, array queries, right? So this is what says the expressive power is same for both of these, right? So what are basic relational algebra queries? The queries that can be formulated using some operators that we have already seen so far. For example, with pi, projection, selection, Cartesian product, union, probably the set difference, then rename operator, intersection, then comes the natural join, right? It can be left outer join, or say conditional join first. It can be left outer join, or it can be right outer join. It can be one both, full outer, even division as well. So all these are basic relational algebra queries, for example, right? These are the operators basically that we used to formulate using this one. And for TRCs, we have seen how we formulate, right? So understand, if I'm saying that I have this query, right, and I can formulate the TRC query for my this statement, right? It's not necessary. And understand, this TRC queries have, their basic limitations as well, right? It's not like that for every statement you can formulate a TRC query. And understand, let me just show you how and why I'm just saying this statement. It means what? Simply, I mean to say that there are certain statements for which we cannot formulate TRC queries, right? So queries fail to express using TRC, or if I can say relational algebra at the same point of time, right? For example, what I mean to say is, can you formulate the query for counting of records? Does any of your TRC or relational algebra query, can you write to form some statement that count the number of records? Even if I say you need to formulate some queries that count attribute values, not only attribute values, I'm saying to count the attribute values, right? If I say you need to find the sum of attribute values, these are what your aggregate functions. These we will see in the SQL part. I can say you find the average of attribute values. Just think, can you formulate the relational algebra query or TRC query? Basically, no. And this is what, if I'm saying that I cannot formulate the TRC query for counting the attribute values, then definitely I will not be able to formulate the relational algebra query for the same, right? Because the reason is they both have the same expressive power, right? See, understand, I'm just writing a simple SQL statement. Probably you are already familiar, the basic one. I am saying that select, let's say, count star, from where? From, let's say, some employee table, right? Where, what's the condition of selection? Where, let's say, gender equals to female. So what actually this query will do? It will take all the female employees and you will say how many female employees are there in the employee table. This is what the number, this is counting. So not possible for this. Not possible if one your relational algebra or even your TRC, right? So this is what the limitation. Probably they can ask you in the exam, It can be, and some questions have already, you can see they have already asked in some competitive exams, right? They are just saying that you need to find the scenarios where TRC fails, right? They will be there, some statement will be given as a part of options, and probably in the semester exams you can find this such type of questions, right? So if we will see that how these things are working, this is what my selection operation condition, this is my projection, and this is my table, right? So we will that this part we will see in SQL part, right? I have a good example here that can be, understand by using TRC, a very good example. But again, I am just leaving this on you. I mean, if you have, I mean, you should try at least, right? You should able to try. If I'm saying this one, unsafe TRC, it's a kind of example that when you can fall in infinite loop, right? This is an example of this part here, right? The question is something like this one. I have a table. I'm just explaining the example here. Probably you should try this one. Why this fails to stop fall in infinite loop. I have a table relation that is family. I have some parent information, some child, and child's date of birth, DOB. Right. See, first query is you need to retrieve. Okay, you need to find out, let's say, relational algebra for what? Let's say for each, because the thing is, if your relational algebra, see, if your relational algebra query is falling in infinite loop, then definitely TRC query will also fall in infinite loop because same expressive powers, right? So since we have previously covered relational algebra, TRC is done right now. So first you should try to formulate for relational algebra for what? Each parent youngest child, right? I think this should be possible using your relational algebra query, right? But now my second question is you need to find it with the SIDs of grandparents. You need to find the SIDs or probably the parent IDs, you can say, of grandparents of some specific child. If I say you need to find the grandparents of some specific child whose name is some Matthias. This is the name of child, right? So under child, you will be having a name Matthias. You need to retrieve the grandparents. So you will have first parent, then grandparent, then great grandparents. I think you should give a try for this one, right? And the third is this. You will understand this should fall into some infinite loop. You will understand if you try to solve. But if I say you need to find the descendants, right? You need to find the descendants of some parent. Let's say I'm saying Mike, some Mike, not Matthias this time. Okay, descendants of some parent Mike, right? So it will what go back. See, this thing is okay. You will just formulate. I mean, when you will try for this one, right? So descendants, when you will try to find out the relational algebra query, you will go here till third generation. Basically, the meaning, the descendant means to say, right? You will go till third generation only. Basically, there is a constant length that probably we will be working on, right? So this will not fall into infinite loop. But the second one, yeah, definitely. So you can just retrieve and you can just try to formulate. Let me know. We'll explain you if you have practiced and understood. Try to understood formulate the query for this part here, right? Okay. With this one, I think we have completed this part here. And TRC, I think this is more than sufficient for your TRC queries here, right? So just let me know. I mean, if you face any issue in understanding any of the concept of TRC here. right? Okay, let me pause this video.